In this lesson, we are going to learn about equations of circles, and we're going to write the equation for a circle and then graph it. So in this one, you can first see that we have the equation of a circle, which you did do in geometry very briefly. So if you recognize this equation, that would be y. I don't expect you to remember it, though, necessarily. So you'll notice that it says x minus h quantity squared plus y minus k quantity squared equals r squared. R in this case stands for our radius. And then our center is HK, just like it's our center for parabolas also. The one major difference is that both the x and the y are squared. So anytime you have an equation, we've gone through lots this year, when we have like an x to the first, we know that that's a straight line. When I have an x squared, we know that that's a parabola, either up or down. When I had a y squared, so like x equals y squared, we had a sideways parabola. When I have an x squared and a y squared in my problem, that's a circle. So when you see both of them are squared, that's how you know and recognize that it's a circle. If only one is squared, it would be either an up or down or a side-to-side parabola. So now to apply this, we're going to write the equation. So we're going to plug these into our formula, and then we're going to graph them. So for the first one, just like point-slope form and our equations for parabolas, the value you put in here, the equation has a minus sign. So we're for both parts for this. So we're actually going to end up putting the opposite in. So when you think for the first one, this is h and this is k and then this is r. I would say x minus h. Well, h is a negative 1. So that's how I would write that. If you want to go straight to x plus 1 squared and just put the opposite, that's fine. You don't have to show this first step here. So then y minus a negative 5 squared, so we'd write y plus 5 quantity squared equals r squared, which would be 2. And if you want to jump straight to the 4 there because you can square that 2 in your head, perfectly fine. So there's the equation. And then to graph this, you can graph without writing the equation. You start at your center, which is negative 1, negative 5. And we already have the dot there. And then your radius is 2. So to sketch it, you're going to go up 2, right 2, down 2, and left 2. And that's going to give you enough of a basis to sketch, so you're going to just draw a circle from there. Mine tend to be, this one's not a perfect circle, right? It's obviously in sketch. If we were doing this properly, we really should pull out some compasses, but we're not going to do that for one day. As long as you have a decent sketch on here, we know that you could put a compass on here and draw a perfect circle. So that's not something that we're actually practicing here. We're just sketching them. Number 2, this one now says endpoints of the diameter. So this really, I know my circle somehow is going to be like this. Wow, that was really bad. How about that? So I know my endpoints are there, which means my center's somewhere in the middle, right? Maybe there. It looks like there. I'm eyeballing it. How do I know for sure where the center of my circle is? How am I going to find that point? That's why yesterday we practiced finding points using our midpoint or our distance formula. So to find the middle between the 2 points they give me, so let me just erase all this stuff. To find the middle, because that's really what I want here, right? Wouldn't these endpoints, the middle would be the center? I'm going to use the midpoint formula. So to find my center, I'm going to use midpoint. So I'm going to do negative 4 plus 4 divided by 2. That's my x's, right? And then you add your y's and divide by 2. So make that a 1, how about? 1 plus a negative 5 divided by 2. So I would get 0 divided by 2, which is 0. And I would get negative 4 divided by 2, which is negative 2. So my center is 0, negative 2, which I think that's where I put it when I eyeballed it, right? So I did pretty good. The other thing I need to find then to write the equation is my radius. So my radius is going to be this value right here, how far away they are from each other. So hopefully you recognize to do my radius I would use a distance formula. So I would use the ordered pair 0, negative 2, and negative 4, 1. Or I could choose this ordered pair if that's what I would prefer. Doesn't matter which one you pick, but you're going to find the distance between them. So I have negative 4, 1, 0, negative 2, and to find my radius, I use distance formula. So I'm going to say distance equals the square root of, and if you remember how we label those, this would be x1, y1, x2, y2. So I say y2 or x2 minus x1, so 0 minus a negative 4 squared plus y2 minus y1. 0 minus a negative 4 would be 4, right? 4 squared is 16. And then negative 1 minus, or excuse me, negative 2 minus 1 is negative 3. Negative 3 squared is 9. So my distance would be the square root of 25, which the square root of 25 is 5. So my distance, which in this case really is my radius, is 5. Now that I found both of those, I can actually write the equation for this circle. So I'm going to use this information right here, and I'm going to write my answer, which is what they asked for, an equation for each circle. So I'm going to say x minus 0, which do I write x minus 0? X minus 0 squared. I think, wouldn't we just write that as x squared? Because x minus 0 is x. So x squared plus y plus 2 squared equals r squared. 5 squared is 25. If you're confused where I got these, remember this is h and this is k and this is my r, so when I square the 5 I get 25. And I'm going off of our equation for a circle formula that we were given at the beginning. So there's my answer. And then to graph this even more accurately, I'm going to go ahead and count 5 up, 5 to the right, 5 to the bottom, 5 to the left. And then I'm going to try to hit all these circles. This will be really interesting. See how well I do. Oh, that's a pretty good circle. Alright, so there's my sketch. Again, you could use a compass for that if you really wanted to. Last one we're going to do like this. And this one is the one that seems to be really tricky for people, so make sure you kind of pay attention to this. They give us a center of 3, negative 2. So I have that point graphed on the graph you see. And they say tangent to the y-axis. So you have to think back to geometry. What does it mean to be tangent to a line? When you're tangent, that means you're just touching that line at one spot, right? Tangent to the y-axis. So remember, this is the y-axis. If it's tangent to it, my circle touches it like right here, but nowhere else. So if I draw this circle, whoops, I'd cross it again, wouldn't I? So that point can't be what means it's tangent. So for me to be tangent to it, any circle I draw here, I can't cross the y-axis twice. So see how here I've crossed it twice? That's not tangent. I need to just touch it in one spot. Well, the only way that would happen is if my point was right here. Because now when I draw my circle, I would just touch there. So they're really, by telling you it's tangent, they're giving you this point right here, which in turn actually gives you your radius, because you can count horizontally. This is 3 units. So they're really telling me my r equals 3. So here's your h and k. Now that we found your r, we can substitute that into the formula, which is x minus h, quantity squared, plus y minus k, so in this case y plus 2 squared, equals r squared. R squared would be 9. So there is my answer. If I want to sketch the graph, I would continue with my radius of 3 to the right, or excuse me, to the top, to the right, and to the bottom. And then connect those circles. That one's really pathetic. And there is my circle. If you have any questions on that, make sure you let me know.